Okay, ladies and gentlemen, this is going to be our last video for Chapter 7A. We need to touch just a little bit on scientific notation, and I know you've been doing scientific notation for years and years and years, and it's one of those things that you probably already have mastered by now, and I know that they cover scientific notation in your science classes, but let's just look over it for a minute because it is still math, okay? So this won't take very long at all. If you notice, this page of notes is just one-sided. We've only got a couple examples down here. I'm going to stick with the odds. You'll be responsible for the evens. What is scientific notation? What's the point of it? Why does it exist? Scientific notation is meant to help you express really, really big numbers and really, really small numbers. Because if we have a really, really big number like 54 trillion or something like that, who wants to write in all of those zeros? So here's how it works. If we are going from standard form, which is the regular form of a number, into scientific notation, you need to move the decimal point until it is at the right of the first number, okay? So always after the first number. Then you need to count the number of spaces that you moved that decimal point. Okay, because that's going to be your new exponent. All right. If the decimal point moved left, the exponent should be positive. I want you, if you have a highlighter, to highlight this part. If you go left, it should be positive. And that's a little weird because a lot of people think if you move left, shouldn't it be negative because you're moving in a negative direction? Well, if you're going from standard form to scientific notation, it's the opposite. All right. And if you move to the right, you go negative for your exponent. All right. So back up here for a second. Scientific notation is usually written like 2.3. You'll have your number times 10 to a certain exponent, whatever, how many spaces you moved. Okay, so we'll look at an example and you'll see what I mean. If you're going from scientific notation back into standard form, you need to note whether the exponent is negative or positive because that'll tell you which way to move. If it's positive, you're going to go to the right. That's the way it should be, correct? And if it is negative, we got to go to the left. All right. And when you're done, insert zeros or commas where you need them. All right. So let's look at this. Number 55. This is in standard form. This is the regular form of this number, but we're going to put it into scientific notation. And how do we do that? First step says move the decimal point until it is at the right of the first number. My first number is 4. So I got to move it until it is to the right of 4, so right here. So that means I move it 2 places. Okay? Remember that number 2. So I'm going to rewrite this 4.08 times 10 to some exponent. It's got to be 2 because that's how many places I moved it, but is it positive or negative? I moved to the right, so if I move to the right, the exponent should be negative. So just like that. That's it. All right, 57. This is a really, really big number. This one was really, really small. Okay, so see what I mean? It helps you write really big and really small numbers. So right now my decimal sits right here. It's not always written, but it's right there. And I want it to be after the first number, so that means right here after 7, because 7 is my first number. So let's move it and count. 1, 2, 3, 4, 5, 6. It moves 6 places. So now I have 7.6 times 10 to the 6th power. Let me look and see if it should be positive or negative. I move to the left, so it should be positive. Okay. Number 59. 9.56 times 10 to the negative 5th. Okay, now this one's in scientific notation. I want to write it in standard form. All right. So I need to note whether my exponent is negative or positive. For this one, it is negative. So that means if it's negative, I need to move it to the left that many places, meaning whatever the exponent is. All right. So my exponent is 5, so that means I'm going to the left this way 5 places. Ready? 1, 2, 3, 4, 5. Okay. Now insert zeros, commas, whatever you need. Let's see. 1, 2, 3, 4. So my answer, I'm going to rewrite it so that I don't have these little lines at the bottom. It's 0.00000956. That's my number in standard form. All right, next one, number 61. We're once again going from scientific notation into standard form. So note the exponent, it is positive, so that means I'm going to the right this time. 3.18, move it 6 times. 1, 2, 3, 4, 5, 6. Okay, insert zeros. And rewrite your answer. Let's add our commas where we need to. 3180000. So after every group of 3, you need a comma. So this number is 3,180,000. That's it. All right. There we go. 56, 58, 60, 62, the evens, they are all your responsibility. So scientific notation, tomorrow we have to do our NWEA testing, so we're not going to spend any time in class really going over it because, like I said, scientific notation is something that you really should know by now. We will have a review day before our test, and I will do a couple review examples of scientific notation, but honestly, guys, you should get this. All right, we've been doing it for years. If you really, really, absolutely just need my help with scientific notation, please come and see me and I'll make time to help you out, okay? So that's it for this chapter. Do your summary questions. I'll see you guys later.